Hello students, welcome to lecture series of Mathematics 1. I am Hitesh Manglani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss topic that is total derivatives of chapter partial derivatives. So what is the meaning of total derivative? So if u is equal to f of xy, so if u is a function of xy, where x is a function of t and y is a function of t, then u is a function of t and is called the composite function of a single variable t. So here you can see in the diagram u is a function of x and x and y are function of t. Now du by dt will be del u by del x into dx by dt plus del u by del y into dy by dt, because here u is a function of two variables, so here we will write down del u by del x, and x is a function of only single variable, that is t, so we will write down dx by dt. So del means it is a symbol of partial derivative and d is a symbol of ordinary derivative. So here again u is a function of x and y, therefore we will write down del u by del y, and y is a function of single variable t, so we will write down dy by dt. So this is called total derivative of u. This is called total derivative of u. Now if u is a function of x, y, z, where x is a function of t, y is a function of t, z is a function of t, then u is a function of t, and this is called the composite function of single variable t. Now let us understand this with the help of diagram. So here as you can see in the diagram, u is a function of x, y and z, and x, y and z are function of t. So overall du by dt is equal to del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. So this is du by dt. So here again u is a function of three variables. So whenever u is a function of two or more than two variables, then we will use del symbol. And if x, y and z are function of only single variable t, so whenever it is a function of single variable, then we will use symbol d. So du by dt is equal to del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. So this is also called total derivative of u for three variables. Now let us discuss examples related to this topic. So first example, that is find dw by dt if w is equal to xy plus z, x is equal to cos t, y is equal to sin t and z is equal to t. So here w is equal to xy plus z. So first of all we will find out del w by del x. That means we will take partial differentiation of w with respect to x. So if we take partial derivative of w with respect to x, then y is a constant. So y will be as it is and derivative of x is 1. Okay. And z is a constant. So second term, that is a constant. So derivative of constant term is 0. Therefore del w by del x is equal to y. Now think about del w by del y. That means we will have to partially differentiate w with respect to y. So x and z will be a constant. So here x will be as it is and derivative of y is 1. And second term, that is z, which is constant, so it is 0. Now we will find out del w by del z. That means x and y both will be constant, because if we partially differentiate w with respect to z, then x and y are constant. So first term is a constant, so derivative of that term will be 0. So derivative of second term, that is z, so derivative of second term is 1. Now dx by dt, so x is equal to cos t, so dx by dt will be minus sin t, because derivative of cos t is minus sin t. And what is y? Y is sin t, so dy by dt is equal to cos t, and z is equal to t, so dz by dt is equal to 1, because derivative of t with respect to t is 1. Now using the concept of total derivative, dw by dt can be written as del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. So we have found all these. So now putting all this in this result, so del w by del x, that is y, and dx by dt, that is minus sin t. So it will be y into minus sin t plus, what is del w by del y? It is x, and dy by dt is cos t. So it will be x into cos t plus del w by del z is 1 and dz by dt is also 1. So it will be 1. So if we simplify this result, then it will be y into minus sin t plus x into cos t plus 1. Now what is y? Y is sin t. So replacing y by sin t and x by cos t. So it will be sin t into minus sin t plus cos t into cos t plus 1. So this can be written as minus sin square t plus cos square t plus 1. Now we know that sin square theta plus cos square theta is 1. So 1 minus sin square theta will be cos square theta. So here 1 minus sin square t will be cos square t. So it will be cos square t plus cos square t, and it will be 2 cos square t. So this is answer of dw by dt. Now let us discuss theory, that is if z is equal to f of xy, that means if z is a function of xy where x is a function of uv and y is also function of uv, then z is a function of uv, and this is called the composite function of two variables u and v. Now let us understand this concept with the help of diagram. So here, as you can see in the diagram, z is a function of x and y, and x and y are functions of u and v. So here first of all, del z by del u will be del z by del x into del x by del u plus second part, that is del z by del y into del y by del u. So this is del z by del u. Here you can see that z is a function of two variables, that is x and y are also function of two variables. Therefore everywhere here it is del. So as we have discussed earlier, whenever it is a function of two or more than two variable, then we will use symbol, that is del. Now del z by del v will be del z by del x into del x by del v plus del z by del y into del y by del v. Now let us discuss examples related to this. So find del w by del r and del w by del s in terms of r and s if w is equal to x plus 2y plus z square, where x is equal to r divided by s, y is equal to r square plus log s, and z is equal to 2r. So here w is x plus 2y plus z square. So we have to find out del w by del r. So as we have discussed earlier, del w by del r can be written as del w by del x into del x by del r plus del w by del y into del y by del r plus del w by del z into del z by del r. Now del w by del x, that means we will have to partially differentiate w with respect to x. So if we partially differentiate w with respect to x, that means y and z will be a constant. So derivative of first term will be 1 because first term is x, and second term, that is 2y, and y is a constant. So derivative of second term is 0, and third term, that is a z square, and derivative of z square will also be a 0. So del w by del x is 1. Now del x by del r, that means we will have to partially differentiate x with respect to r. Now what is x? It is r divided by s. So if we partially differentiate x with respect to r, then derivative of r with respect to r, that is 1. So it will be 1 divided by s. Now think about del w by del y. So we know that w is equal to x plus 2y plus z square. So del w by del y will be 2 into derivative of y, that is 1. So it will be 2. And first term, that is x, so derivative of that term will be 0 because it is a constant, and last term, that is z square, so it is a constant, so derivative of that term is also 0. Now del y by del r. So what is y? Y is r square plus log s. So if we take partial differentiation of y with respect to r, then it will be 2r, and s is a constant, so derivative of log s will be 0. So del y by del r is 2r. Now think about del w by del z. So here w is equal to x plus 2y plus z square. So del w by del z will be 2z, because first term, that is x, which is a constant, so derivative of x is 0, and second term it is 2y, so derivative of 2y is 0, and derivative of z square is 2z. Now del z by del r. So what is z? Z is 2r. So if we take partial differentiation of z with respect to r, then it will be 2 into 1, because derivative of r is 1. So del w by del r is equal to 1 divided by s plus 4r plus 4z. But here we will have to find del w by del r in terms of r and s. Therefore, we will replace z by 2r. So replacing z by 2r. So here it will be 1 by s plus 4r plus 4 into 2r. So it will be 1 by s plus 4r plus 8r. So it will be 1 by s plus 12r. So del w by del r is equal to 1 by s plus 12r. Now we will find out del w by del s. So del w by del s will be del w by del x into del x by del s plus del w by del y into del y by del s plus del w by del z into del z by del s. Now del w by del x we have found earlier, which is 1. Now del x by del s. So what is x? X is r divided by s. So here we have to take partial differentiation of x with respect to s. So r will be as it is, and derivative of 1 by s with respect to s will be minus 1 divided by s square. So this will be minus r divided by s square. Now del w by del y, we have already found that del w by del y, which is 2, and del y by del s. So what is y? So here we know that y is r square plus log s. So if we take partial differentiation of y with respect to s, then r square, that is the first term, which is constant, because if we are taking partial differentiation with respect to s, then r is a constant. So derivative of that term will be 0, and second term, that is log s. So we know that derivative of log x is 1 divided by x. So it will be 1 divided by s. Now del w by del z is 2z. We have found that earlier. And del z by del s. We know that z is 2r. So if we take partial derivative of z with respect to s, then r is a constant. So derivative of 2r will be 0. Therefore del z by del s is 0. So this will be minus r divided by s square plus 2 by s. So this is answer of del w by del s. Now let us discuss next example, that is, if u is a function of x by y, y by z, z by x, then prove that x del u by del x plus y del u by del y plus z del u by del z is equal to 0. So here, suppose x by y is equal to L, y by z is equal to m, and z by x is equal to n. So therefore now u will be a function of L, m and n. Therefore u is a function of L, m and n. So if we draw the diagram, so you can see in the diagram u is a function of L, m and n, and L, m and n are functions of x, y and z. So overall L, m and n are functions of x, y and z. So here first of all we will find out del u by del x. So if we find out del u by del x, then you know that how to write del u by del x from this diagram. So if we write del u by del x, then del u by del x is equal to del u by del L into del L by del x plus del u by del m into del m by del x plus del u by del n into del n by del x. Here everywhere it is del, because u is a function of 3 variables, lmn, and lmn are functions of 3 variables. Okay. So this is del u by del x. So here first of all del u by del L, we have to find out del u by del L, but we cannot find out del u by del L because here u is a function of L, m, n. So we will simply write down del u by del L as it is, because we don't know what is the function. Okay, so del u by del L will be as it is, and del L by del x. So there is a relationship between L and x. So L is equal to x divided by y. Therefore we can find out del L by del x. So if we find out del L by del x, then it will be 1 divided by y, because derivative of x is 1. Okay. Now del u by del m, so it will be as it is again, del u by del m, because u is a function of lmn and we don't know what is the function, therefore del u by del m will be as it is, and del m by del x. So here m is equal to y by z. So if we partially differentiate m with respect to x, then y and z are constant, so derivative of that term will be 0. Therefore del m by del x is 0. Now del u by del n will be as it is, and we will have to find out del n by del x. So what is n? It is z by x. So that means we will have to take partial differentiation of n with respect to x. So z will be as it is, and derivative of 1 divided by x with respect to x will be minus 1 divided by x square. So this will be minus z by x square. So this can be written as, if we multiply both side by x, then it will be x del u by del x is equal to x by y into del u by del l minus z by x into del u by del n, because x divided by x square, so it will be minus z divided by x. So this is result 1. Now same way we will find out del u by del y. So del u by del y can be written as del u by del l into del l by del y plus del u by del m into del m by del y plus del u by del n into del n by del y. So this is del u by del y. Now del u by del l will be as it is, and think about del l by del y. So we know that L is x divided by y. So if we are taking partial differentiation of L, then x will be as it is, and derivative of 1 divided by y will be minus 1 divided by y square. So del L by del y is equal to minus x divided by y square, plus del u by del m will be as it is, and we know that m is equal to y divided by z. So if we take partial differentiation of m with respect to y, then it will be 1 divided by z. Now del u by del n will be as it is, and what is n? It is z by x. So we are taking partial differentiation of n with respect to y, then x and z are constant, so naturally its derivative will be 0. So this is del u by del y. Now multiplying both side by y. So if we multiply both side by y, then it will be y del u by del y is equal to minus x divided by y into del u by del l plus y divided by z into del u by del m. So this is result number 2. Now same way we will find out del u by del z. So del u by del z will be del u by del l into del l by del z plus del u by del m into del m by del z plus del u by del n into del n by del z. Now del u by del l will be as it is, and we know that L is equal to x divided by y. So if we take partial differentiation of L with respect to z, then x and y are constant, so del L by del z will be 0. Now what is m? It is y divided by z. So if we take partial differentiation of m with respect to z, then y will be as it is, and derivative of 1 divided by z is minus 1 divided by z square. So this will be minus y divided by z square. Now del u by del n will be as it is, and what is n? It is z divided by x. So if we take partial differentiation of n with respect to z, then it is 1 divided by x. Now multiplying by z both sides, so it will be z del u by del z is equal to minus y by z into del u by del m plus z divided by x into del u by del n. So this is result number 3. Now we will add result 1, 2 and 3. So adding result 1, 2 and 3. So we will get x del u by del x plus y del u by del y plus z del u by del z is equal to 0. So in today's lecture, we have discussed about total derivative and examples related to total derivative. Thank you for watching today's lecture. I will see you in the next lecture.